Sneeze once and your body releases a torrent of air at speeds exceeding 100 miles per hour. This expulsion isn't just a reflex, it's a sophisticated defense mechanism. Deep within your nasal passages, millions of tiny hairs called cilia detect invaders like dust or pollen. These particles may be invisible to the naked eye, yet they set off a chain reaction. Your body isn't simply ridding itself of irritants, it's protecting your respiratory system from potentially harmful pathogens. With each sneeze, your nose deploys a powerful arsenal designed to shield you from unseen threats. The stakes are higher than they might appear. The trigger for a sneeze often begins with the trigeminal nerve, the largest cranial nerve in your body. When irritants touch your nasal lining, this nerve sends a rapid signal to your brain's sneeze center. Located in the lower brainstem, the sneeze center coordinates the complex choreography of sneezing. It's like a conductor orchestrating a symphony of involuntary actions. Within milliseconds, your brain sends messages to your diaphragm, chest muscles, and throat. This cohesive effort results in a sudden, forceful expulsion of air. Far from random, every sneeze is a precisely timed response to protect your airways. Your sneezes are more than just powerful expulsions, they're remarkably efficient. Each sneeze can project thousands of microscopic droplets into the air, reaching distances up to 26 feet. These droplets, filled with saliva and mucus, are formidable carriers of germs. The force generated by sneezing is enough to dislodge particles stuck in the upper respiratory tract. Surprisingly, this explosive mechanism serves a dual purpose. It clears out irritants while also signaling your immune system to sustain vigilance. The sneeze is an elegant balance between brute force and biological finesse. The act of sneezing involves not just your nose but a network of muscles and nerves working in unison. As your chest expands, the buildup of pressure forces your vocal cords to close temporarily. This closure results in a sudden release that propels air through your nasal cavity. It's a tightly controlled explosion that utilizes the entire respiratory system. Your eyes often shut involuntarily, a reflex linked to the facial nerves. Every component of this mechanism is precisely tuned to maximize efficiency and effectiveness in clearing your nasal passages. This intricate dance ensures your body's defenses remain intact. Sneezing is a universal human experience, yet its frequency varies dramatically. Some people sneeze once, while others experience sneezing fits triggered by sunlight, a phenomenon known as the photic sneeze reflex. Affecting about 18 to 35% of the population, this reflex is due to a cross-wiring in the brain where the signals for light and sneezing overlap. Such variations highlight the diversity in how human bodies respond to stimuli. Despite these differences, the underlying mechanism remains the same. A sophisticated system designed to protect you from the constant barrage of microscopic intruders. Deep within your nasal cavity, specialized cells called goblet cells produce mucus. This slippery substance traps particles like dust or pollen before they can travel further into your respiratory tract. When these particles are detected, the nearby cilia, tiny hair-like structures, begin to oscillate at speeds up to 15 cycles per second. This movement propels mucus toward the pharynx where it can be swallowed or expelled. The cilia's synchronized motion is akin to a conveyor belt efficiently removing unwanted debris. This invisible dance of mucus and cilia forms the first line of defense in your body's complex sneeze mechanism. The molecular cascade that leads to a sneeze starts with receptors in your nose detecting irritants. These receptors release histamines, signaling molecules that cause blood vessels to dilate. This dilation increases blood flow and triggers the nerve endings in your nasal passages. The resulting signal is transmitted to the brainstem's sneeze center, a hub of neuronal activity. Here, neurotransmitters like acetylcholine relay instructions to various muscle groups, ensuring the sneeze is synchronized. This cascade takes mere seconds, yet involves a complex interplay of chemical signals finely tuned to maximize your body's protective response. Inside your diaphragm, the main muscle of respiration, muscle fibers contract sharply during a sneeze. This contraction is fueled by calcium ions which flood into muscle cells upon receiving nerve signals. The influx of calcium triggers the sliding of actin and myosin, two proteins that generate force. This rapid contraction compresses the lungs, increasing air pressure dramatically. When the vocal cords open, the pressure is released as a sneeze. This muscular coordination showcases the remarkable efficiency of your body's reflexive actions. It's a meticulously orchestrated event where each component plays a critical role in expelling irritants. Your immune system also has a stake in sneezing. Mast cells embedded in your nasal passages release histamines when activated. These chemicals not only prompt sneezing but also alert the immune system to potential threats. Cytokines, signaling proteins, are released into your bloodstream, mobilizing white blood cells to the site of irritation. This rapid response ensures that any pathogens are quickly targeted and neutralized. In this way, sneezing serves a dual function. It expels irritants while simultaneously galvanizing your body's immune defenses. This dual action underscores the sneeze's role as a frontline protector. The neurological control of sneezing involves a precise feedback loop. Sensory neurons in your nasal passages detect irritants and send signals to the brainstem. The sneeze center then processes this information, determining the appropriate response. Once the sneeze is initiated, sensory feedback from the expelled air informs the brain of the sneeze's completion. This feedback loop ensures that sneezing is only triggered when necessary, preventing overreaction to benign stimuli. It's a finely tuned system where each sneeze is an evidence-based decision made in real time by your body's intricate neural network. Sneezing is usually an effective defense, but what happens when it goes awry? If your nasal passages are chronically inflamed, as in allergic rhinitis, sneezes may become frequent or uncontrolled. This condition affects about 30% of adults and can cause repeated sneezing fits. Here, the immune system overreacts to harmless substances like pollen or pet dander, leading to excessive histamine release. This overactivation makes sneezing less protective and more burdensome. It's a reminder that while your body's mechanisms are robust, they can occasionally misfire, turning a protective reflex into a persistent problem. The limits of sneezing are tested under extreme conditions. For instance, some people can suppress a sneeze, but this can have unexpected consequences. Holding in a sneeze can create pressure up to 5 times greater than normal. In rare cases, this can rupture a blood vessel or even cause a small fracture in a rib. While the urge to avoid sneezing in public is understandable, it highlights how the system is designed to operate freely. Suppressing this reflex can be more harmful than letting it occur naturally. The body's systems are best left to perform as evolution intended. Sneezing can reach impressive extremes. Donna Griffiths holds the world record for the longest sneezing fit, which lasted 978 days. This prolonged reflex suggests an extraordinary sensitivity of her nasal receptors. While extreme, this case provides insights into how the sneeze reflex can be driven by persistent stimuli or heightened sensitivity. Such cases help scientists understand the thresholds at which the sneeze reflex operates. They reveal the remarkable adaptability and variability inherent in human biology. Even in such extraordinary circumstances, the underlying mechanism remains remarkably consistent. In certain neurological disorders, sneezing can become a symptom of deeper issues. Conditions like epilepsy or brainstem lesions may disrupt the sneeze reflex, either enhancing or inhibiting it. These cases illustrate the vital role the brainstem plays in regulating this reflex. When its function is compromised, the precise coordination required for sneezing falters. Understanding these failures offers valuable insights into the broader workings of the nervous system. It underscores how intertwined your bodily processes are, with each relying on intricate neural pathways to function seamlessly. Sneezing is often underestimated, yet it serves as a critical defense mechanism. The most surprising fact? A single sneeze can expel up to 40,000 droplets. This act not only clears irritants from your nose but also communicates a need for vigilance among your immune cells. Consider this: sneezing is one of the few reflexes that operates via a direct neural pathway from the brainstem, bypassing conscious thought. This level of autonomy ensures protection even when you're not aware of a threat. It reframes sneezing as an essential, automatic guardian of your respiratory health.